So we finished the DAX code, which is press enter, and excuse me, this the calculated column is gonna be shown in here. And as we did in DAX code, we basically try to take the value of the adjusted close price of Apple on the last trading day. Okay, so you can see this number. Okay, this 229.54 is basically the adjusted close price for Apple on the last trading day. So it doesn't matter which date you are looking at. All right, you may be looking at a very different date. This is always the adjusted close price for Apple on the last trading day. Okay, so if you go all the way down to the end, you can see this 229.54 exactly. It's the same as the adjusted close for Apple on the last trading day in this entire data table. Okay, which is October 9th, 2024. So let's go back to the report view, and we can add this this newly constructed column to our view. So I'll just drag it to and drop it off here to the y-axis. All right. So for each date, okay, because our x-axis is each date. All right, and each date there's just one single value for the last adjusted close underscore C. All right. You can see here Power BI mathematically sum that value. Okay, that's just single value. So whether you do a sum of it, you do an average of it, a minimum or maximum, doesn't matter. Okay, for each single day, as we can see from the table view, right? For each single day, this value of the column is just one single number, right? So regardless if you sum it or average it or take the minimum or maximum, it's just the same value. All right, so you can, for example, you can change this sum to minimum, right? Still you just see this flat line. Okay, so the flat line basically tells you, well, here this column basically shows the adjusted close price for Apple for the last trading day in this data sample. So regardless which date you're looking at, it's always the same adjusted close for the last trading day for Apple. So it's going to be a flat line. Okay. Of course, that's not what we wanted, right? We wanted to have the adjusted close for Apple at the end of each month. All right. So, well, that's our original intention, right? To do this video. Okay. So the reason I try to show you this flat line at the beginning is I'm going to introduce another concept called mirror. Okay, and once you learn mirror, you can see how we can just construct that monthly close chart. Okay, very easily. Okay, well, still, before we get to the concept of mirror, this important column we just constructed is going to be helpful. You will see. Okay, you will see why it's helpful just in a minute. So now let's construct a monthly chart. So to introduce a new monthly chart, I will just click on the blank area of this report page, and I'm going to click on this line chart. All right. So I'll have year month on the x-axis. Okay. So instead of using the year month defined within this historical daily data table, actually I'm going to use this, the year month defined in this Bravo date data table. Okay, that's important because if you take a look at our data model, Bravo date serves as the kind of the what we call the dimension table, which define the date dimension, and the date dimension is connected to all the fact tables. All right, so it's usually a good practice to use date directly from this dimension table instead of using date from those fact tables. Okay, so that's what I'm going to do here. I'm going to choose this year month in the date table and drag it to be the x-axis. All right, and I'm going to use this last adjusted close underscore C as the y-axis. Well, notice by default, Power BI kind of want to use the sum of this calculated column as a y-axis, but that doesn't make sense. All right, you can see the value of this sum is going to be like 5,000 or 6,000. Okay, it's crazy. So the reason, if you take a look at the table view of this data set, if you're talking about January 2023, there's many different days in January. Okay, and in that zero, we are just summing up all those values of this column as long as the date is belong to January 2023. So, well, that really doesn't make sense. You don't want to sum the price up over different days, right? So instead of using this sum, I'm going to use the minimum. You can use the minimum, the maximum, or the average. That will be more reasonable. Okay, I'm going to use the minimum. So what I'm doing here, across different days in January, I'm taking the minimum of those values across different days in January. Okay, apparently those values are the same for each date. So the minimum is still this 229.54. But at least it's not a summation, which doesn't really make any sense. Okay, so the minimum still is reasonable here, at least. Okay, so this is the minimum price for Apple. I'm sorry, this is the last trading day's price for Apple across all the months. Okay, basically this line is the same as this flat line. Okay, but still we don't want a flat line. We still want to see how the price fluctuates at the end of each month. Okay, so to do that, instead of using this calculated column, I'm going to introduce a new thing called a mirror. So first of all, I'm actually going to copy the definition for this calculated column. All right, I'll just copy this entire definition for the last adjusted close underscore C. All right, and then I'm going to introduce a new mirror. So I'm going to go to, again, click on this data table and click on a new mirror. And I'm going to basically paste what I just copied here. All right, of course I cannot use the same data field name, so I'm going to call this mirror last adjusted close without that underscore C. All right, but notice the entire definition of this mirror is the same as that calculated column. I'm basically just copying and pasting that DAX code. So I will just click on enter, and this mirror come into place. All right, and I'm going to put it in the y-axis as well. Well, now you see this mirror. I just give you a better view of this. This mirror has the same definition. This dark blue line has the same definition as the calculated column. However, you see this guy fluctuates over time. It's not going to be a flat line anymore. So how come with the exact same DAX code or definition, a mirror actually shows a different pattern than a calculated column? All right, that's the thing we're going to explain just in a minute.